Good morning, children. We learned about different kinds of motion. In the first chapter, we learned about speed. Today, let us learn more on speed.
We have read that speed of a moving body is the quantity which tells how fast or slow the body is in motion. The speed of a moving body is defined as the distance traveled by the body in unit time. That is, speed is equal to distance traveled divided by time taken. The SI unit of speed is meter per second. Now suppose if a body travels in a straight line and covers equal distances in equal intervals of time, we can say that the body is in uniform motion. In other words, an object in uniform motion travels in the same direction at the same speed. Now suppose a car is moving on the road. Its path may not be a straight line, or if the distances covered by it in equal intervals of time are not equal, then we can say that the motion of the body is non-uniform motion. In cases when bodies move with non-uniform speed, we specify their average speed. The average speed is calculated by finding the ratio of the total distance travelled by the body to the total time taken in the journey. That is, average speed is equal to total distance divided by total time. Now let us learn about another important topic, that is weight. How weight is related to mass. We have learned that matter has mass and occupies space. The mass of an object is the amount of matter contained in it. The SI unit of mass is kilogram. In the 17th century, the famous English physicist Sir Isaac Newton discovered that every object in the universe attracts every other object in its neighborhood. This force is known as gravitational force or gravity. The earth attracts everything on it or moving near it towards its center. The force of the earth's gravity on an object depends on the mass of the object. We call this force the object's weight. Thus, the weight of an object is the force of earth's gravity acting on it. Since weight is a force, its SI unit is Newton, the unit of force. 1 Newton is nearly the force of attraction of Earth on a mass of 0.1 kg or 100 gram. The other unit of weight is kilogram force, symbol is kgf, where 1 kgf is equal to 9.8 Newton, which is taken as 10 Newton approximately. We have already learned that the mass of a body is measured by a beam balance, whereas the weight of the body is measured by an instrument called as spring balance. The mass of a body remains constant everywhere, whereas the weight of an object will be different if it is taken to the moon or other planets. Since the moon's gravity is about 1/6 of the earth's gravity, an object that weighs 60 kg on the earth will weigh only 10 kg on the moon. Now it is clear that the weight of a body depends on its mass. So the formula of weight is equal to mass into force of gravity. That is, W is equal to m into g. Thus, it is clear that mass and weight are not same. So we'll continue in the next class. Thank you, children.